Hi, my name is Cam Thomas, and this is my Physics 2 Lab 1 report on the charging tapes experiment. So our purpose in this experiment was to analyze and observe how charged tapes interact and calculate the charge values on one of the chosen tapes. So these are the steps and procedures to start the experiment. First, we want to create a U-tape by placing a tape on top of another and quickly peeling it off, leaving the base on the table. Next, we want to test the tape on known charged objects to identify what charge the tape is, using your hand, books, or a plastic pen, and many others to help just identify the overall charge. Next, we want to use a measuring tape or ruler to measure the distance that the U-tape has on another U-tape that's placed over it. And so we can see where it starts repelling it, and then we want to measure that distance to use for our later calculations. Then lastly, we want to use two separate computation models in GlowScript to calculate the desired responses to the research questions of the lab. One will be based more on your observed values, while another will be more calculated to get the lines of charge values that we expect and want to compare. These are some of the formulas, theories, and observed values we use throughout the experiment. For theories, we have Newton's third law, with every action/force having an equal and opposite reaction/force. Next, we have Newton's second law, which is F equals ma, which we will then use to make F equals mg, which is just the gravitational force being exerted on the tapes as in compared to the electrical force. We then have law of conservation of charge, which is within an isolated system, the total electric charge should stay consistent. Next, we have our constants with gravity and k, which k just being the constant for 1 over 4 pi epsilon naught, just simplified. Some of our observed values is the mass, length, width, and distance that the tapes started separating at a stable gap. Some of the equations we use are for the weight, which is the mg, like I mentioned earlier, for the gravitational force. And then we also have Coulomb's law, which is the most important equation that we're using throughout this lab. For our system and surroundings, I'd said that the system was just the tapes and whatever object is being used for the comparison for the electrical fields, and then the surroundings would be everything else that is that is nearby. For the estimated charge, I compared the value we got from the m times g calculation, being weight or W here, to Coulomb's law, and then using that, I solved for Q to then get the estimated charge of one of the tapes. And as we tested the U tapes compared to other various objects, I decided that it should be positively charged based off of how it reacted to neutral and other positive objects. This is some of the coding that I used for part one of the experiment, and there's nothing too much to note here just yet, but it is shown here how we got some of the values, and a lot had to be messed around with, so I'm not too uh, confident in how it all turned out, but this is just some of the stuff we got here. Same with part two, but it's a lot messier, and yeah, this is just the outcome of that. So for our conclusions and comparisons, I saw that the lines of charge section of the code is more accurate than the single point charge because it distributes the charge throughout the entire strip of the tape rather than just a single point in the middle. This would closer represent reality and would more likely produce a more appropriate number for Q in the equation. Here are the numbers I used to try to prove that, with the second model having a closer approximation to the gravitational pull, which it should be neutralizing, and compared to the first model at least. And then the electrical charge of each tape is just measured here at the bottom, worthy of note. Some assumptions made for analysis and errors. Some external forces, such as air resistance, were ignored. We treated both tapes as having the same charge for simplicity. The tape was treated as a single point charge. The mass of the tape wasn't measured, but instead was estimated with a calculation. The charge could have been lost in the handling of the tape if my hands weren't precise when moving it around. And then the edited GlowScript code could, and more than likely, has some mistakes in the scripting and /or calculations. For our what ifs, we have what if the positive and negative signs were switched, protons being negative and electrons being positive, and what would change? The results of the experiment would be identical, as the assignment of positive and negative is purely a human-made convention, Changing the labels would only change how we refer to the relationships between the objects, but not how they function in reality. Like charges will still repel, and opposite charges will still attract. Thank you for watching.